everyone, my name is Michael Tucker with Maverick Power. Today I'm going to talk to you about our power distribution unit. This is a 500 kVA PDU, 4,600 pounds, 40 deep by 60 wide by 88.5 tall. Let's go ahead and open this up. Purpose of this PDU is to have our secondary voltage for a customer with incoming 480 volts. We can have different voltages coming off our secondary side safely and the small footprint as well. This is a 500 kVA PDU. We have it tapped at 415. We can also tap it at 400 and 208. Right now, 415, we're set at 696 amps. Our major components in this PDU, we have our main breaker on our primary side, followed by all of our feeder breakers on our secondary side. We have three main components on our controls. We have our PQM that monitors our primary side. Our BFM monitors all the secondary side with our breakers as well. And our HMI screen has all that information on it. Our main footprint of this PDU is 60 wide by 44 deep by 88.5 tall, which is a nice small footprint for data centers. Our main design of this PDU is a very nice compact unit. We have our transformer in the back, main breaker followed by all of our feeder breaker. This is a section separated from our control section, which is very nice and compact with all of our main three components. Operation of this, we have this PDU is a 500 kVA, so basically we would shut this main breaker. 480 volt goes through the transformer. 415 on the other side is feeding all of our feeder breakers, which is monitored by all of our three main components. This is our HMI. This has all of our information for our PDU. You can see our primary side, our main breaker. Our secondary side is our transformer right there. And all of our feeders are on the secondary side. The information that we can see, going to the main breaker, you can see all of our line to neutrals, voltages, amperages, kVAR, kW, K-factor. All of our information's in there. You can scroll through and see it. Our phase angles, voltage, and amperage. The same thing we can see on our secondary side as well, same information. And as well as all of our feeder breakers. You can go through each one and check that as well. You can see all of our information for our KW, our amperages, our neutral amperages, all the information is there. We can actually go to see our alarms as well, which can be recorded and all time stamped. We can go to our settings. Right now we have all this enabled. We can change our voltage settings to 415, 400, or 208. And that is basically the gist of our HMI. This is our Maverick Power placard. This has all of our information on it. This is a UL 891. It shows our address where this was built, the electrical characteristics, the input's 480 volt at 600 amp, 60 hertz, 3-phase, 3-wire and a ground. Our output's gonna be 415, 400, or 208. 415 is gonna be at 696 amps, 400 is gonna be 722 amps, and 208 is gonna be 1388 amps. Right now we have this set at 415. We can also tap it to 400, which is just changing a couple of taps. If we wanted to do 208, we'll have to add some wires on our secondary side and up our CTs from 800 to 2000 because we're going to be set at 1388 amps. We're at 6500 KAIC. This is a type 1 transformer with a heat rise K factor of 150 Celsius, which is 308 Fahrenheit above ambient temperature. This particular PDU is 415-2. We can make and customize PDUs for various sizes, but that is basically our placard. Safety features, we have our SPD, which is our surge protection device, which is protecting the secondary side with all of our feeder breakers and components through that. All these breakers have a trip set rating of 600 for the main breaker and 400 for all the feeder breakers. We also have breakers and fuses to protect all of our components as well. Here we have interlocks. We can actually lock our HMI out, and customer can have their own lockout code to actually access settings and stuff like that. All these breakers are going to have many protection features with trips and all the settings. My surge protection device, it is actually protecting my secondary side BFM and everything that coincides there. Everything is protected through breakers and fuses. Up top is where all my Modbus cables are landed for my communication with all my components. 24 volt above that. Then we have my 120 volt above that for customer. So what we're going to talk about just for a quick second is our main breaker on our primary side and our feeder breakers on our secondary side of this 500 kVA transformer. Our main breaker is an 800 amp frame, but we have it tripped at 600. Our feeder breakers are going to be 600 amp frame set at 400 amp trip. These all have open, close, and trip, which will show up on my touch screen, our HMI. These are LSIG, long-term, short-term, instantaneous, and ground fault. Our main breaker is set at 600 amp because we have it tapped at 415. So that's 696 amps capacity. So 600 amp is plenty for that. Next, we'll jump over to our control section and check that out. For our controls, we have our 3 main components. Our Modbus is communicating with all these components, and the customer will communicate with this through a serial, through our HMI, and they can also plug into our BFM and our PQM to see all the information there as well. We have our 480 volt coming in, tapped on our primary side, with our 120 coming out, feeding up to our 120 volt supply with our 24 volt, and all that is fed up through our terminal blocks up top. Next up, we have our BFM. Well, this whole BFM is actually for all of our feeder breakers. So on the very bottom, we have our open and close for all of our feeder breakers. We also have our CTs for our feeder breakers fed in one of the modules as well. And also we have our HMI on our BFM, so you can see all your information on there, your 415 volt, any other information you want to see, your IP addresses. On the very top here, we have our 415 coming in to our voltage module. And then we also have our ground and neutral CT on this BFM as well. If we keep going up, as I said, this is our 120 volt by 24 volt power supply feeding up top. Right above that is our PQM. That's our power quality meter. This is our 480 volt coming into this guy. This is all communicating with our main breaker on our primary side of the transformer. My main breaker CTs are there. We also have Modbus on all of our units. Our main 3 components, our Turk screen, our PQM, our BFM. Our surge protection device is actually protecting our secondary side with our BFM. Everything is protected through fuses and breakers. We also have our Modbus. That's our communication between our main components, PQ and BFM. Then we have our 24 volt and 120 volt up top. That is going to be the main gist of our interior. We do have our neutral CT in the very, very back bottom back there, and our ground CT here is at 100 amp. That's going to be 800 amp CT, as well as our primary and secondary side of this transformer is also going to be 800 amp CTs. Because we're tapped at 415, we're set at 696 amps capacity on our main breaker. So that is why we're at 600 amp trip. So after our BFM, we have, as I said, our power supply, 120 coming in, 24 volt coming out. We have our PQM. This is on my primary side of the transformer. We also make these PDUs where this can be on the secondary side as well. But for this unit, we have our PQM that's coinciding with our main breaker. We have our main breaker CTs on the primary side reading here. We also have 480 volt coming into this PQM, and we have 120 volt actually feeding this and powering it up. And also we have our Modbus cables that communicate with our PQM, BFM, and our Turk. All these breakers are going to have many protection features with trips and all the settings. We also have protections with our SPD. Everything's fused and breakered through all of our components as well. We have interlocks. We can actually lock our HMI out, and customer can have their own lockout code to actually access settings and stuff like that. So again, I'm Michael Tucker. Thanks everyone for watching the video. Please feel free to reach out to me at mtucker@maverickpower.com or 469-223-0921. And don't forget to bring your best, get the job done, win as a team, and deliver well.